So here for part 5, we have partial fraction decomposition. A rational expression can be rewritten as a sum of two or more simpler rational expressions. So if you look at x plus 7 all over x squared minus x minus 6, it can be rewritten as two different expressions. Now what you've done back in the past is you've actually started with these two expressions and then worked your way back up to this right here. And the way you did that was you had to find a common denominator. So your common denominator would end up being x minus 3. You'd have to multiply both sides by whatever you're missing from your denominator. And then you would go ahead and distribute your 2 to your x, 2 to your 2, negative 1 to your x, negative 1 to your negative 3. Add them together and you get an x plus 7 on top. And then on the bottom, if you FOILed x plus 2 times x minus 3, you would end up getting your x squared minus x minus 6. So, anytime you have a fraction on the right side of an equation, this is what we call a partial fraction. Partial fraction. So what that means is these are your partial fractions. Together, they make up your partial fraction decomposition. The best thing to do is to look in your book. You want to look at the steps on page 495. Those may help you also along with example 6 here. So what we have is we have to write our partial fraction decomposition of this fraction. We need to split it up into two. So your first step, what you need to do is you need to factor your denominator. So if we factor our denominator, what that's going to do is that's going to give us x squared plus 6x plus 8. We need to find factors of 8 to add up to a 6. So these factors are going to end up being 2 and 4. So we can go ahead and write this as x plus 2 times x plus 4. And what that's going to allow us to do is that's going to allow us to use our x plus 2 and our x plus 4 as the denominators for each of your parentheses, or sorry, for each of your terms. So we're going to have an x plus 2 here, and we're going to have an x plus 4 here. Now what goes on the top? Well, on top you're going to have an a. This is going to be the coefficient, or the term, constant term, of your first fraction, and then we're going to have a b, which would be the constant term of your second fraction. So now what we're going to have to do for your second step is you need to find an LCM, the least common multiplier, LCD, the least common denominator. And when we do that, we're going to have to multiply each of our terms, a times whatever you're missing in this fraction, which would be an x plus 4. We're going to have to multiply b times your x plus 2. So let's go ahead and write that out. So a times x plus 4 plus b times x plus 2, and that's going to give us an ax plus 4x plus bx plus a2b. And what we're going to do is this is going to be your numerator that you're going to have in order to help solve for a and b. Well, the problem is we're going to need to set this equal to your original numerator, which is x plus 8. And what we're going to do next is you need to combine anything with an x. So you have your ax and your bx. Those would be combined. And you can actually factor out an x from each of those. And you can say x times a plus b. And then we can put our, whoops, that's not supposed to be a 4x, that's supposed to be a 4a. Let's get rid of that. 4a. So then we're going to have a 4a plus a 2b is equal to x plus 8. And what we have here is something we did way back when. You can set like terms equal to each other. So notice your x is attached to an a plus a b. Here your x is attached to a 1. So we're going to set a plus b equal to 1. And then notice you also have a 4a plus 2b. That we're going to set equal to your 8, because 8 is not attached to an x, neither is 4a and 2b. So we're going to have 4a plus 2b equals 8. And notice you have a system of two equations with two unknowns. If we solve this system, this will give us a and b. So we are going to multiply the top by, I'm going to multiply by -2. That way we can get rid of our b's first. So we're going to have a -2a minus 2b is equal to -2. And then we're going to end up with, on the bottom, 4a plus 2b is equal to 8. So if we cancel out your 2b's, or not 2b, those are gone. That's going to give you a 2a is equal to 6, which means a is equal to 3. So we know what goes above this fraction up here now. In order to figure out where your b is, well, we know that a plus b is equal to 1. So if we say 3 plus b is equal to 1, that means b then will be equal to a -2, which is going to go up here. So your third step, finally, is just to write your decomposition. Or your partial fractions. So we're going to have our final answer is going to be a, which is 3 over x plus 2. And you either put a plus and -2, or you put a -2 over x plus 4. Either way will work. And that is how you write a partial fraction decomposition.